Uh, Hello, everyone. Today I'm with Hussein to solve another problem which is related to derivatives. But I believe Hussein needs to use other concepts in geometry to find a solution. So,
Mhm.
hello, Hussein. How are you
Hi,
doing?
Amir. I'm good. Thank you. Thank you. Pretty
Yeah,
good.
yeah, I'm good. Thanks. I have a problem for you. Let me
Uh-huh.
just read the problem. Figure shows a circle with radius 4 inscribed in the parabola y
Mm-hmm.
equals x squared divided by 4.
Mm-hmm.
Find the center of the circle. So as you can see in the figure, we have a blue circle with a
Mm-hmm.
radius of 4,
Mm-hmm.
which is inscribed inside the parabola with the color of brown or orange, whatever.
Mm-hmm.
So I want you to find the center, the coordinate of the center of the circle. Definitely the x value of the center is 0, but you need to find the y-intercept of the center of the circle.
Right. So
Uh,
this
so
center is the coordinate is 0, and let's say C is the Y.
C, correct. Yes,
Okay.
and I need you to obtain C,
Mm-hmm.
uh, given the the illustration that you have.
Yeah. Okay. And this parabola, the equation is Y equal x squared divided by 4.
Correct. It
Okay.
means that on every point this relationship holds
Mm-hmm.
on the parabola, on
Okay.
the brown curve. Yeah.
Mm-hmm. Okay, understood. And I think when we say inscribe, it means that
Yeah.
wherever the circle is touching the parabola at those points, if you draw a tangent line to the parabola, it's going to be also a tangent line to the circle, the line
And
also.
that is going to be perpendicular to the radius of the circle. So that's
Okay.
correct. At the intersection of the circle and parabola, you have a point. At that point, the tangent to the parabola and circle is perpendicular to the radius of the circle. That's correct.
Okay, so you're saying that these two lines, the blue line and the red lines,
Yeah,
they
they are
are
perpendicular.
perpendicular, right?
Correct.
Yeah,
That's
yeah, you're
correct.
right. Okay, okay. Yeah, I think I know. I kind of have some idea how to solve this, how to approach this problem. So
Okay.
I think one thing is important is to recognize the equation of a circle. So if you have a circle with the center of, let's say, um, center of x naught and y naught, and the radius of r, then the
Yeah.
general equation for that circle is x minus x naught squared plus y minus y naught squared equal r squared. And then
Correct.
so if we use the information given in this problem, which says the center is 0 and c and the radius is 4, if we substitute these parameters into the general equation of circle, then
Yeah.
uh, I'm going to have x squared plus uh, y minus c squared equal r squared is 4 squared, which is 16.
Mm-hmm.
Okay, so
Correct.
this is the equation of this circle, and um, I think I see three unknowns here. So x, y, and c, but I kind of have idea um, about the relationship between y and x at the tangent points,
Yeah.
which is like one here and one there. At these 2 points, I know that y is equal x squared divided by 4, because that the coordinate is governed by the equation of the parabola which is given.
Yes, yeah, the red point that you just mentioned is on both circle and parabola.
Right.
Correct.
I have another one here. So if I substitute that in the circle of equation, then I'm going to have x squared plus x squared divided by 4 minus c squared equals 16. And this is where the circle and the parabola are touching.
That's correct.
Okay,
that's correct. So you reduced actually the equation, the unknown, by 1.
Right.
So you just have 2 unknowns right now, x and c.
So where circle and parabola are intersecting, then I have this equation which has 2 unknowns, x and c. And I have one equation, so I need to look for another equation to be able to solve this problem. And the parameters that we're looking for is c. So let me see. That equation, that extra equation that I'm looking for, I think comes from the slope of the tangent line and the perpendicular line. So I know if we get back to the figure, I know that the slope, the slope of the tangent line, if I call this, if I call this angle alpha, the slope of the blue line is it can be found by taking the derivative of the parabola equation. So tangent of alpha,
which is the slope,
which is the slope of blue line, is equal to y prime, which is x squared divided by 4 prime, which is x divided by 2.
That's correct.
And then I know from geometry that if 2 lines are perpendicular, the slope of one is negative of reciprocal of the slope of another one. In other words, if I call this angle beta, the angle of the red line, then tangent of beta is -1 over tangent of alpha, because these 2 lines are perpendicular. And from there, I can say tangent of beta is -2 divided by x.
Correct.
This is because blue line and red line are perpendicular. And and then and then I have
you have tangent of beta, then you can establish a relationship between c and tangent of beta and x. You can show where under for the positive x, where the x is, where the y x.
So this is if this is x, so this is y. So the coordinate of this point is x and y. And then so from here to here,
that is c.
From here to here is c. So this portion is c minus y.
Correct. Yes.
And then tangent of beta is front to the side, so is c minus y divided by x, because the side is x, the front is c minus front is this line,
Yes.
c minus y, and then side is this line, which is x, and then tangent of beta is front to the side. So c
Correct.
minus y to the
Definition of
x.
tangent, yeah.
Okay. Now, if I use those information, let me put that together here. So tangent of beta, which was -2 divided by x, now I know that it is equal to c minus y divided by x. And then if I replace y with x
You again use
squared,
the parabola relation.
right, because the relationship between x and y governed by the parabola equation. So I'm going to use that. So I have c minus x squared divided by 4 divided by x. And then, so I'm going to focus on this side of parabola, specifically this point. And then because this point has x, at this point, x is greater than 0, x is greater than 0. So I can just simply cancel x on both sides of the equation. So
Yes.
x is, if x is greater than 0, then I think I wanted to cancel this x from the denominator on both sides of the
denominator,
equation.
You know that the x is positive and also non-zero. So you can simply cancel that because it's non-zero.
So -2 is going to be equal to c minus x squared divided by 4. And I think, okay, I think I can simplify this and say x squared divided by 4 is equal to c plus 2. I'm not mistaken. And
yeah, that's true.
Okay.
That's correct.
And then I think I can, okay.
Now you have the equation for the circle.
Exactly.
You can call it number, you can call this one number 2. You can call the circle equation number 1.
2 and 1, and then so I'm going to replace x squared divided by 4 in the first equation by c plus 2. So I'm going to have what was that, x squared?
Yes.
Plus, instead of the x squared divided by 4 here, I'm going to
just replace it with c plus 2.
C plus 2, and the rest is minus c squared equal to 16. Okay. So I have 1 plus 2, or 1 and 2.
1 and 2. Based on 1 and 2, you
so I concluded that x squared plus c plus 2 minus c squared equals 16. And then, so c and minus c cancel out, and I have x squared plus 2 squared equals 16. So x squared is equal to 16 minus 4, which is equal to 12.
Yes.
Okay.
That's correct.
So x squared is 12, and
so actually you use the derivative concept and the slope of the of two lines which are perpendicular to get rid of one of the unknowns, which was c. So you actually obtain the value of the x for the point that you showed on the figure. So it is actually a square root of 12. Plus minus a square root of,
Right. So this x here is a square root of 12. And then, so I think I'm going to use, so if I go back to the first equation,
Yeah, for the circle.
Yeah, let me copy this equation and paste it here.
Sure.
So in this equation, I have obtained x squared. So if I replace it, I can get the value for c, which I was looking for originally, right? So x squared is 12 plus 12 divided by 4 minus c squared equals 16. Then, so I have 12 divided by 4 minus c squared equals 16 minus 12. So I moved this 12 to the other side of the equation and changed the sign. And now I have 3 minus c squared equal 4.
Yes.
Okay, and then I
consider
think
the square root of both sides.
Right. So 3 minus c equal plus minus 2.
Correct.
So I'm taking a square root from both sides. And then so c is equal to either 3 minus 2, which is equal to 1, or 3 plus 2, which is equal to 5. So I have two answers. So let me go back to the figure. So in this figure, this is the value for c, and then 1 is 1. I have two answers, 1 and 5, and I know that from this figure, so
c minus
has to be equal than y.
Greater than y. C has to be
yeah,
greater
it has to be
than y.
greater than y, and then y here. Let me see what is the y. So I have x squared, so I can obtain y.
Yes, x squared was 12. You obtained.
So x squared. Yeah, up here I obtain x squared. So x squared is 12. Then y is equal x squared. This is divided by 4. This is the equation of parabola. So I have 12 divided by 4, which is 3. And then I know that c has to be greater than y, which is 3. And then, up here I have two answers for this c. Only one of them is greater than 3. So I think the acceptable answer is 5. So knowing that c has to be greater than 3, then c equal 5 is my answer. So
that is absolutely correct.
So the center of circle is at 0 and 5.
That is correct. Yes.
Okay.
For the last step, you just actually looked at the geometry of the problem, and it was obvious that c minus y is greater than 0. In other words, c is greater than y, which is 3, and then you chose the right answer, which is c equals to 5.
Right.
Okay, thank you, Hussein. And
right, no problem.
So from the very beginning, you had the equation for a circle.
Right.
From the figure, actually, you knew that the center of the circle is it has just y-intercept with the 0 value for x, and then you use the parabola equation to get rid of y in the circle equation. For equation number 1, in there you just have two unknowns, x and c. You actually use the derivative concept to obtain the slope of parabola at the red point that you showed, which has the coordinate of x and y, correct? And then you had two perpendicular lines because the tangent of that line is perpendicular to the radius of the circle. The circle is inscribed by the parabola. So you use that concept, and you obtain the tangent of the red line, which is negative reciprocal of tangent of the blue line. Then you use that property to actually get rid of one of the unknowns, which was C. And then in the following page, you actually obtain the value of x squared, or x, which was 12. X squared was 12. So then you use the equation of circle again and solve that. You obtained C with two possible answers. And again, using the geometry and the illustration of the problem, you concluded that C cannot be less than Y, which is 3. So you actually chose C equals to 5. Yeah, different. That was a combination of concepts in geometry and derivatives and
right. It was
yeah.
it was a very comprehensive problem.
Yeah, I like this problem. That's why
Yeah.
we wanted to solve this for this video.
Right.
Hopefully viewers learned from this video, and thank you very much, Hossein, for
no problem.
the
If
time.
viewers have any questions, they can leave a comment down below this video. We get back to them. We answer those questions as soon as we can.
Correct. Yeah, and if you like the video, please subscribe to our channel for future videos, and hopefully you will learn more from our channel. And until the next video, take care. Thank you, Hossein. Bye.
Thank you. Bye, everyone.